Okay, hello students. In this video, I want to continue with working on lesson number 3.3. This is about, there are not many questions, only 5 or 7 questions. And this is based on you can use long division method and also you can use synthetic division. So I'm going to use the synthetic division. This is just a quick review of what you guys did in Algebra 2. Like the question is asked. Find the question. This is the very first question. Practice problem. Let's do one problem on this. Find the question and the remainder using synthetic division. Now, what is synthetic division? You can see the polynomial that is in the numerator. That means it is 2x squared. This is the numerator, and this polynomial is divided by the denominator, binomial x minus 2. Now, when you want to use the synthetic division, remember you have to make two lines like this perpendicular. And then this 2, which you see, this 2 is plug in outside. So let me use this as a, so if it is minus 2, you put a plus 2 here. Then figure out what are the coefficients of the the polynomial. So you can see there is a 2 here. So 2 is one of the coefficient. Then the coefficient of a linear term is minus 3 and the number by itself is plus 4. So this is how it's write down. Now drop down this to right here and then multiply this one. So 2 times 2 gives you plus 4 and this together will be combined to get plus 1. Then again you multiply this one, plus 2 times 1 is 2. So 2 times 1 is 2 and this together will give you 6. And you can see the last number is put in the box to show that that's the remainder. So that whatever you get here is the remainder. Now, remainder theorem says also that if a polynomial is divided by this, then I can call this whole thing as f of x. So that means remainder theorem. What is the remainder theorem means? Theorem says if a polynomial is divided by the x minus a, then f of a is the remainder. So in this case, if I had to plug in f of this one, 2, f of 2, then you'll end up getting 6. That's what this means. Now, what is the quotient here? So the question is, so we already got the remainder is plus 6. What is the quotient? And the quotient is this one. So you have two numbers here. So in the beginning, the degree, it was a quadratic. So the degree was 2. And one of the factor is already, you are dividing by x. So that means, so what is remaining is the other one will be, this will be whatever the 2 which is here. You put 2x and then plus 1. And then this is the quotient. So when you have dividend is divisor times quotient plus remainder. So the one that we have given the dividend is 2x squared. Here it is, this one, 2x squared minus 3x plus 4. So this equals, the divisor is x, I think, minus 2. Okay. And the quotient that we got is this one, 2x plus 1. And the remainder is this 6. So this is Euclidean form, where that's all they're asking you. Not the question was asking only to figure out what is the question, but I still went on trying to show this is the main concept to understand here. And you can clearly see if I call this is f of x, let's say if this is f of x, and if I plug in f of 2, it means you plug in 2 right here, it is 2 minus 2 is 0. So which is 0, right? So all you get is this whole thing becomes 0 and you're left with plus 6. So the remainder is 6. So that's the remainder theorem. So I hope this makes sense. Let's do the next. One thing you need to take note also is just imagine if you did get this as 0, let's say instead of 6 now, if it was 0, then what does that means is that means the x plus 2, the one that you are going to divide, so this x plus 2 is going to be a factor. So what is factor theorem? So let's write down that. So factor theorem says if anything if the remainder, that means f of a, whatever that, if f of a is 0 for the polynomial, then x minus a becomes the x minus a is a factor. So in other words, let's see if this was 0. I'm just imagining this was 0. And when you plug in that 2, so 2 minus 2 is 0. So this will be 0. Everything becomes 0. So this 6 will become 0. And that's why this x minus a becomes a factor. We'll take one more example and see how it works. Before even I want to show the problem number 2, it's better to get an idea of, let's see if I have 17 is divided by 5. It means it is 17 is divided by 5. So you will see this 5 times 3 is 15, and then we subtract. So there you go, change the sign, and you get 2. So this is the remainder. This is the dividend. This is the quotient, and this is the remainder, right? I mean divisor. So that means when you divide 17 divided by 5, it means what you get is the quotient is 3. So this is the quotient plus the remainder is 2. 2 divided by 5 is 3 to 5th mixed fraction, right? Another way to write is if you multiply 5 in each of this, so you multiply 5, multiply 5, and that I will multiply the other side. See, sorry. So multiply. It was 3 and multiply by 5 and multiply by 5. So cross out this. So you get 17 equals 5 times 3 and plus 2. So this is another way to write the whole thing. So when you divide, so now this is with the help of numbers, but when you write the polynomial, so the polynomial will look different. See, if px is, and it is divided by factor, let's say x minus a, we can extend the same idea of the one that I show 17 divided by 5. We can extend this to, remember, if this this is 17 divided by what? If it was 15 and divide by 5, and you can see this is 15 divided by 5, and this becomes 3. So it is 3. Quotient is 3 plus there is no remainder. See? So it is like 0 remainder. It means this is the quotient. So then we say this 5. So when you divide and if the remainder is 0, say 5 is a factor of 15. So when the remainder is 0, we say it is 15. And likewise, we will see if there is a polynomial px and when divided by some binomial x minus a, all you're going to get is a quotient, that means some quotient, and plus the remainder function, and divide by the divisor, that is x minus a in this case. Or you can also write any polynomial px is quotient, whatever the divisor x minus a times the quotient qx and plus the remainder. So sometimes the remainder doesn't have to be a number. It could be also an expression we will see in the later one, something like x plus 3 kind of thing, and you can get like this. So that's what we are trying to write down. In the next question, we are going to use this idea here. Let's look at this. So let's see how we can write this. In this example, you see that. So the px is this one is your px, and this is that x minus a. Now this x plus 4, we can write it as x minus of minus 4, and this is that a. So in the synthetic division, you're going to write this minus 4 outside, and then all the coefficients of the 1, then plus 4, so it is 1 plus 4, then plus 5, and then plus 3. You want to make sure this is written in the standard form. Now this is in the standard form. Sometimes it could be 4x square here plus 5x and then plus x cube and then plus 3. Then you will have to rearrange this to write in the standard form. So right now we are good. And this number plus 3 constant goes last. And then the next trick is you drop down the very first one So this is 1 because there is a 1 right here. So you drop it down and then multiply my -4 to 1 and put it right below this +4, which is -4. You get 0. Then you multiply this to -4 times 0 is 0. Then this together will be 5. And you multiply this time here. And -5 times 4 is -20. And then you can see this is -17. So the remainder here is -17. So how do we write this whole thing? So now let's put it in the Euclidean form. So what is that Euclidean form is dividend is divisor times the quotient plus the remainder, right? So dividend, this is the dividend, the whole thing x cubed plus 4x squared plus 5x. And this dividend is equal, the divisor is x plus 4. And the quotient you get is from here. So the last row that you get, this one, because the degree of the original was 3. If you see this is a cubic polynomial, and there is a 3 right here. You can see this is 3. So because this degree is 3, so that means you reduce it by 1. That means if this is 1, so what is written down on top here is 2, because if this is 3, the quotient will have a of 2, because eventually when you multiply these two things, we should give you that x cube. That's the reason. So you write this x is already here, so x square. And this one, which one is 1x squared. Then there is a 0, so it is like plus 0x. And the last number is by itself, so plus 5. And that can be written as x plus, oh, I think I forgot. So this is a quotient. And then again, the remainder is -17. So finally, the final answer is x plus 4, x squared plus 5, and then -7, and then you're done. So that's all you're supposed to write in the Euclidean form. That's the question. The question is, what is the quotient? And I hope I make sense. And you can, in this case, this x plus 4, which is right here, this x plus 4, we say it is not a factor of the top part. It means why it is not a factor, because there is a remainder here. If this was 0 right here, then we will say x plus 4 is a factor. So right now it is not a factor, because if you plug in here x equals -4, then what you get is this whole thing becomes 0, and you're left with this -17. So you don't end up getting equal to 0 when you plug in x equals -4. So this factor theorem says this is not a factor. And I hope that helps. In the problem number 3, what's the difference right here is this is a cubic. And you can see it is in the standard form, but you can see there's a quadratic term missing, that it is like this. It's like 0 times x squared. So this term is missing, and then it is -3x and plus 11, the whole thing divided by x plus 4. So you're going to use the same synthetic division. Opposite of plus 4 is -4, and the coefficients of the variable x's will be 1. The leading term, the coefficient is 1. Then the coordinate term, the coefficient is 0. And the linear term is -3. And the constant is plus 11. So this is how you write. Drop down the first one. So this one goes right down. Then multiply -4 to 1, and you write it below the 0, which is -4. Combine this and you get -4. So you're done with that. So let's multiply this one. -4 is positive 16, and this will give you 13. And finally, multiply -4 times this, which will be -52. Okay, and if you get the remainder here will be, so the remainder here will be 41, but minus sign. The question is what, so this becomes -41, but what is the question? So now you have the numbers are this -4 and 13, so your quotient will be 1, this 1, and then x squared, because there is a 3 here, and so you reduce it by 1. So minus 4x and this is plus 13 and you're done. But then if you want to write in the Euclidean form, so this whole thing should be written x cubed minus 3x plus 11 equal, the divisor is x plus 4, and then the quotient is x squared minus 4x plus 13, and the remainder is minus 41, and you're done. Okay, let's move on. What about this question number 4? Let's solve one practice problem of question number 4. You can see there is a degree is 4, so you'll have 5 terms to be written down. The coefficients start with 1 here, so 1, then minus 1, so minus 1, then plus 1, so plus 1, then there is minus 1, so minus 1, and the final there is a plus 2, so that goes plus 2. And in the denominator, the divisor is x minus 2, so opposite of minus 3 you put here plus 3. Drop down this 1, so 3 times 1 is 3. Combine this 2, you get plus 2. Then multiply 3 times 2 is 6. And you combine plus 1, this becomes 7. Then you multiply 3 times 7 is 21. Combine this 2 and you get 20. And 3 times 20 is 60. And 60 and 2 combined is 62. So now the quotient, so how do we write the quotient is because the original one degree is 4. Now the new quotient that you're going to have will be degree 3. So you are putting x raised to 3. But the coefficient, the first coefficient is 1, so that goes right here. Then this 3 reduces by 1, so it becomes x squared. So the number is here is plus 2, that goes right here. Then plus 7, so this 7 goes here, 7x, and then the number is 20, and you're done. That's the quotient. And the remainder is right here, 62. But I want to write also in the Euclidean form, that is a dividend, that means you have x raised to minus x cubed. So the dividend is divisor, in this case is x minus 3. And the quotient that we have is this whole thing cubic. And the remainder is plus 62, and we are done. 62. Okay, sometimes they may give you a fraction. Look at the binomial here. So the first thing is do those 2 lines and write the opposite of this, minus half plus half. So that goes right here. And this is a cubic. So the numbers are 2, and plus 5, and minus 3, and plus 2. So you place them right here on the first row, that is 2, plus 5, minus 3, and plus 2. Now, first step is drop down. The first coefficient drop down, that is plus 2, and then you multiply this outside from here. So half of 2. So half of 2 is 1, so that goes right here. And this together will be 6. And then again you do half of 6. So what is half of 6 is 3. So which becomes 3, and you get 0, see this? And then again half of 0 is 0, so it combines and becomes 2. That's the remainder. So this remainder is 2. And the quotient, so what is the quotient? Because the degree here was, degree is 3, so the quotient will be x squared now. So I'm going to just put a box like this. This is what you're supposed to write. X and then number. So the numbers that we put places, so the plus 2, so this plus 2 goes right here. Then there is a plus 6, so this plus 6. And the 0, so this is 0. That means you're done. This is the quotient. Your quotient is 2x squared plus 6x. That's it. And if you want to write this in the nice form, in the Euclidean form, so the dividend is divisor, which is x minus half. Then the quotient is 2x squared plus 6x, and the remainder is plus 2, and you're done. Okay, with this we end lesson number 3.3, using synthetic division, figure out. So you're going to use the synthetic division to figure out the quotient and the remainder. That's all in this lesson. So let's we make quick another video for the next lesson, that is 3.4. Make sure you are completing the homework which is put in the Cengage.